Vectors in the plane. So the first thing I want to talk about here is the vector. So the vector has an initial point, and that's what we call this down here. That's the initial point. And this point up here is called the terminal point. Now think about what the word initial means. Initial means beginning. So that simply means we're going to start here, and we're going to go in this direction, and we're going to stop here at the terminal point. One big thing to keep in mind with vectors is realize that they are directed line segments. It's not a ray. It doesn't start here and just go on forever. It actually stops at this terminal point here. And at the terminal point, that's where the head of the vector should be. It shouldn't be beyond it, like past it and say, hey, that's my terminal point. It shouldn't be that way. It should stop at that point where it's supposed to stop at the terminal point there, and that's where the head of the vector should be. So this vector here I'm going to call V, the vector V. And what you'll see most of the time when you're dealing with vectors is you'll see this arrow over the top of it, and that represents a vector. And we also have this initial point down here, and call that O and call that P. And it doesn't really matter what we call them. Those are just labels that we can put for points. Now what we're going to do with these vectors is we're going to continue to talk about the characteristics of the vectors, and then we're also going to talk about doing so many different things with these vectors as well. Like we're going to add, subtract, and just various operations that we can actually do with them. So that's where we're going with this. So the next thing I want to talk about is with this vector, we have a direction, and that's what this arrow represents. And it's this long. That's how long this vector is. And that length for a vector is called magnitude. So the way we represent magnitude is we usually write it this way. So we have these single lines here, and then the vector between it, and that simply means that that's the magnitude or the length of the vector. So that is where the definition of a vector comes from. A vector is a quantity that has both magnitude and direction. So again, the definition of vector is a quantity that has both direction and magnitude. Now we're going to talk about vectors on a rectangular coordinate system. So the idea of taking this vector here and putting it on a rectangular coordinate system, and we get. So looking at this vector on the rectangular coordinate system, which we have over here to the right, we can now put other vectors on there and talk about relationships there, like this one. And I can call this vector U. And what I could say about these two vectors, I could say that they're equal. Now the reason why I can say they're equal, because if you look at the distance here between these two, the distance is the same. And also, because they're going in the same direction. Now, that we can see pretty easily too, because notice this, if we think about the idea of slope, like slope of a line, that means I'm going up one, over one, up one, over one, and if you look here, I'm going up one, over one, up one, over one. So we can see here that these are actually going in the same distance as well. So they're the same magnitude and the same distance, and having those two bits of information together, we can say that these two vectors, U and V, are equal. Another thing we can say about these two vectors is we can say these two vectors are also parallel. Not necessarily because they're going in the same direction, but if you think about them as lines, they're never going to cross, are they? No. So therefore, we can look at these as two parallel vectors as well. And that is defined as two vectors are said to be parallel if they have the same or opposite directions. So now when I look at these two vectors, U and V, to say they're equal, now do you guys remember what that meant? That meant vectors are said to be equivalent vectors or equal vectors if they have the same magnitude and direction. Okay, so when we look at these two, they're going in the same direction, so we can say they're equal vectors. We can also say they're parallel vectors because they go in the same or opposite direction. Now there's also other ways to look at a vector here. So let's take this vector v and take half of it. Now notice this, I drew this previously and I'm just going to take half of it. So that would be half of v. So that would be another way to think of that vector. Or I could double v. Now all of those would still be in the same direction. I could also take a negative v, which this takes me in the other direction. So now again, we kind of see how these all look geometrically now. These are all parallel vectors to the 1/2 v, to the regular v, which is the red one, the negative v, which is the blue one going in the opposite direction, and then the u over here on the other side. So now just thinking of these ideas, these are very helpful when we start to think about these vectors. And when we talk about the idea of parallel vectors, now remember what it said here. It said they have the same or the opposite directions, and that's what we see for all of these vectors. We also have a zero vector that we talk about periodically. And to draw a zero vector here, I'm going to do it right on the graph. There is a zero vector right there. I just drew it at the origin. I'll draw another zero vector. There's another zero vector. And that is just denoted by a 0 with the arrow over the top of it. That means zero vector. So we also deal with this as well. So the zero vector we can say is a vector with an initial point and terminal point that are the same. And that is called the zero vector. So we can call the zero vector where the initial and terminal point are the same. We can also say that it is the only vector without a direction. But by convention, we can also consider it to have any direction. So it's a very peculiar vector. So now that is the basic terminology that we'll go over for these vectors in the plane.